Okay. Hi, everyone. We have fireflies with us today. I'm not sure what that exactly means. Oh, hi. Oh, Bernico invited, to record and take notes. Okay, so this is an AI. Is that right, Ola?
Yes, for now, yes.
Yes, I'm learning about AI, everyone, and more. Okay, today we have with us Professor Esa Yartinen. I hope I've pronounced that correctly.
Perfect.
See, I looked it up. And he is with the Faculty of Science and currently conducting some laser research. Now, Esa has a really interesting background, and I'm sure we've given you the link, so I don't want to take up too much of our time with that. And Esa has said, no, don't, just get straight to the point, which is very good advice. But before I do anything, I need to do the welcome to country. If you will all have, just give me a moment. Okay, so here we go. It's very important for us. The Queensland University of Technology, QUT, acknowledges the Turrbal and Yugara as the First Nation owners of the lands where QUT now stands. We pay respect to their elders, laws, customs, and creation spirits. We recognise that these lands have always been places of teaching, research, and learning. QUT acknowledges the important role Aboriginal and Torres Strait Islander people play within the QUT community. And as I'm in Perth, Western Australia, I acknowledge the people of our land, our Noongar people. Now, thank you for that. And now, Esa, I think because we have you on a limited time frame, I'm going to do the first question I'd like to ask. One of the things I saw in your profile was that when you joining QUT, you wanted to focus on developing sensors and photocatalysts to safeguard society and protect their environment. What does that mean, and how has your journey with that been, and what inspired you? Too many questions.
No, it's a large question though, but I'll try and give some insight into that. And I think for me, I've always been interested in helping humanity, society, through being able to create new knowledge. And before coming to QUT, I was working at CSIRO, and that was its mantra, doing research for the public good. And that's continued on when I came here. And for me, my research area is in physics, and basically what I do is I look at interacting light with material, and that's one of two purposes. When you do that, you can create interesting material properties, and that's where the photocatalysis stuff comes into it, so chemical reactions. Or the other thing is when you interact light with materials, you can learn something about the material. In particular, you can work out what type of material it is, and that's where my sensor work has really sort of evolved. So the idea there is that when you hit the light beam onto your material, you get a small amount of light coming back, and if you analyze that light, it tells you, for instance, what that material is and how hot it is and what other properties of that material. So you can use it as a way of diagnosing the material. So when it comes to sensing things that the public may be interested in, so some examples of that would be perhaps a contaminated waterway where you have contaminated water. You don't really want to go and touch it. You don't want to be in contact with it. So this technology that I've been working on is basically hitting the water sample with the laser light, getting enough light coming back from that water, and you can work out what sort of impurities are in the water. So that's been an area I've been involved in for about 15 years now, through a range of different projects with a range of really, really good people. And it's sort of progressed to the point now where we can shoot a laser beam a distance of say 20 or 30 meters into a plume of a cloud of material and work out whether there's any toxic material in that cloud. So you can imagine that would be kind of use for firefighters. They have to go to an industrial blaze, and before they enter the premises where the thing is on fire, they need to be sure that they're not going to be harmed in going into that environment. So this sort of technology really, the sensor technology really helps those sorts of people, those first responders, understand what they're dealing with and going in before they go in and do their work in that space. And obviously that sort of stuff lends itself quite easily to a defense setting as well, you know. So you can imagine that in a different defense scenario, you may have material there that could harm the personnel. So the defense want to know whether that's the case or not before their personnel enter into a particular region. And I've got to be upfront right from the get-go in that, you know, I work in a defense context, but that's not the only context. But it's really important to me that the research I do is used to save people and help people, as opposed to the other, because I just could not do that. That would be completely against my values and my core beliefs. So it's really important to me that any work I do applied in a defense setting is basically there to save lives, and not the opposite.
Do you actually express this openly with your potential clients? Okay, that's
100%.
great.
So I do that with not only, and defense is completely aware of this. They are completely aware of this. When you enter into sort of a research collaboration with them or any form of collaboration, you're upfront and open, and that's really important in any collaboration. Is that you're not sort of keeping things away, because if they're not interested in working with you because of your beliefs, then the relationship will stall and we'll have problems. So it's really important, if you have these beliefs, that you voice them and raise them, and if they're happy with that, then you can continue on.
What I'm starting to think is how that links with, say, policy or the making of policies by, say, government organisations, etc. That becomes a key component for you, and also they need to consider and commit to that, so that any public. Have you got an example
Yes.
for us?
Well, I think, you know, and this is the thing that a lot of people who haven't had much dealings with the defence, the government agencies around defence, would not probably appreciate, is that defence is very, very switched on when it comes to important societal things like environment, ethics, human rights. They are really switched on. They're probably surprisingly so when you first encounter that, because, you know, I think a lot of us have this view that they're this sort of machine that goes in and does whatever, using whatever force is necessary and destroying things like the environment. But they're really switched on with that. In fact, one of the things that I'm currently doing is looking at investigating the material that's on the bottom of boats. Okay, now it sounds a bit boring, but it's basically, if you look at all the liners and cargo vessels that travel the world, um, the amount of fuel they consume is massive, like trillions of dollars in fuel. So if you have something that reduces the efficiency of that transport, so it costs more fuel, then that can have a huge impact on the cost of doing things. So what happens with most ships that are in the water is that they develop algae on the bottom, and people want to get rid of that. So I suggested, well, I could use a laser system to measure and then get rid of it. But, you know, these people, defence, have said that, well, you've got to do it in a way that doesn't leave debris in the water, which can then damage the ecosystems. So this is a thing that's really important to them. And another one is, whenever I talk about some laser project with a defence-minded group, they are very, very switched on to safety. So if there's a risk that people's eyesight will be damaged, there's all these processes that have to go through before you can actually do anything. So they really switched on to all these sorts of things.
Right. That's really interesting, and it's really heartening to know. It sits well with some of my experience with the Navy at one stage developing, but this was like a leadership program, but they were very, very ethical.
Yeah.
Okay. So in terms of some of the other research that you've done, how can you kind of like, how do you see like the end product, if it goes into policy, how do you become aware of what they do with it? You know, because I think that, you know, we churn out research, but
Yep.
what happens to it after that, we're not sure.
Yeah, I think I guess, like, I'm just one component in a much bigger project, and I think when it comes to the bit I provide into the bigger picture, um, it's probably not that adaptable to other things. It's really fit for purpose. So, like I said, you can imagine the sort of sensor systems that I'm working with. They're basically quite small and compact. They're probably 30 kilos, maybe 50 centimeters by 50 centimeters in footprint. So they're not that huge. So I would develop one of these sorts of things with my team. And then they may also have a requirement that this thing has to be on a drone or an autonomous vehicle. So then they would work with other people who do that. And then we would try and couple those two things together. So my bit would sit on top of this vehicle, which the engineers would do the research in and allow the final thing to be greater than the components themselves.
Okay, so it's a real collaboration
Yeah.
process. Now, and just with that, you made a very important comment from our perspective about the importance of stakeholders and
Yeah.
how do you work, what are your views, values around that?
I really enjoy mixing with a whole range of different people with different mindsets, and I think, and also it brings you back to earth as well, because it's quite easy when you've been in academia and been pursuing interesting research to forget how other people work and how they think. And it's just refreshing to meet people who don't thinking in the exactly same way as I do. I find that really enjoyable. And it also gets you to think through not only your the research and what it's for, but like I say, your own views, your own values, your own beliefs, because often you find that I think all of us think that we're easygoing, we're relaxed, and we're inclusive. But it's surprising how, depending on the circumstance, you may find yourself thinking, oh, I hope that didn't sound too arrogant. It's sort of like it's these sorts of things that brings you back to earth is when you mix with this whole range of different people. So I think with stakeholders, mixing with people who are public servants, and they've been their world forever, and they're dealing with a whole framework of hierarchy of rules and guidelines and all the rest of it, and then people that are driving drones or developing drone technology who are a bit more like if you imagine the Microsoft back 30 years ago, where they're wearing jeans and thongs and they've got their lounges and they're doing all their work in a very relaxed format. So bringing all those elements together, I think, is a really interesting thing. And being able to talk to each of those groups is the key. That's the key, is that you need to be able to get your messages across regardless of who you're talking to.
Yeah, so there's that sense of value in respecting each other and what, yeah. Have you
Yeah.
have you ever come across a situation where you've really had to argue and convince? I mean,
Um,
they're sticky areas, but I'm going to ask
yeah.
because you sound as if you'd be good at it.
Well,
You've done it.
I have, and to be honest, the success rate I wouldn't say is more than 50%, because like I say, you've got to appreciate the priorities from another party's perspective.
Yeah.
So just a really simple example, I built these sensor platforms and they work great in the lab, but will they work in a Jeep that's going over rough terrain and bumping all over the place? And there's no point me getting fixated about the technology I've developed because it's just brilliant. It's the world beating. It's the best ever if it's not going to work in the context that the person who needs it wants it to work in. So there's
Yeah.
no point me winning that argument. In fact, that's an argument I lost because they pointed out it's never going to work. I go, well, fair enough. We have to find another way then. So that's where you have to be big enough to go, yeah, you're right. I was wrong. Well, not wrong. I appreciate you're correct, and we have to do things in a different way. So you've really got to take that ownership and not be so stubborn that you can't see where people are trying to go.
It's really great. That's really great because that's the ethos of what we try to get through to, like with our students, because often we get very passionate about the fields that we want. And that's been my experience too. And it's kind of like coming to that middle ground where you're both, able to go forward and do something, produce something constructive,
Yeah.
rather than letting it all fall apart.
And I think
Ola,
one of
do
the,
you
sorry,
go?
I'll just go, if I could add just to that, one of
Yeah,
the more
go.
challenging and difficult things to do is to do that. It's easy to work with people you like. It's very much harder to work with people that you are very fundamentally different with in terms of personality and attitude. But sometimes those people are essential for what you're trying to do. So
Yeah,
you have to find a way. And a lot of this stuff is all about communication, being tolerant, being respectful, and taking a back seat, and that's really key because otherwise you end up just seeking people who think like you, and then you've got a very narrow set of views in that group, so you really do need to, yeah, be big enough to say, I need to work with that individual, even though I don't operate in that way, if you get my drift.
yeah. No, I get your drift. Ola, do you have a question for Esan? Yeah.
Yes, I have one question. I am interested with a policy process on actually starting your research because you collaborate directly with government, let's say organizations, defense,
Yeah.
and not only. Is it difficult to, like you stated straight away at the beginning, that you want to make sure that your research is used correctly and it is not used against humans or
Yeah.
life? So how do you actually conduct that? How you map this process of applying this policy in your research when you start collaborating with organizations?
Yeah, that's a really good question. And I think I guess and it's a complex question, let's be honest. And I think in the first instance, as I said before, you have to be upfront. Even so, informally, you have to let people know what your position is. And then when it comes time to make a framework, an actual framework that policy will be built on, that's when it's time to formalize it and write in restrictions and limitations and the like. And I think I had some experience with this about 4 or 5 years ago, because I'm actually part of a Centre for Advanced Defence Research and Enterprise. It's a centre which is looking at producing things like these sensors that I'm talking about and a range of other things. But that centre is, and if you go to the website, you can see it's called Cadre, is very, very clear in that the work we do is not to create offensive defensive capability. It's always about using it to protect people. That's really the key goal for all of the members of that centre. And I think that once you formalize it, you have a centre, you have the paperwork, you have policy that's written and developed, then it appears in that as a course of practice. So I'll be honest with you, I didn't frame the policy, but I definitely had input in terms of presenting my own views. And your options are, if the centre wants to do something different, then it's your choice. You have to decide, are you comfortable with this or not? And if you're not, then my advice is always to go. You should never do something that goes against your fundamental beliefs.
That's true. You control your research.
Yeah. Does that answer your question, Ola?
Yes, absolutely.
Great. I'm just going to check in on Vinodaya and Nirosha. If you have any questions, you can type them into the chat section and we can read them out. Otherwise, you can just put your camera on or put your hand up and ask the question if you're able to talk.
I have one more question to ask.
Yes, please go.
Very quick one, because we have a lot of students from Cairo. They do my PhD with us, and your background, I think it's something which might interest them as well. And maybe you could tell us more about your first research. I know that you were in Asia as well.
Yeah. So I think, like I said, I started my research career with CSIRO, and the focus there was to do research for public good. That's the intent. And the work I was doing back then was basically in an area called dimensional metrology, which sounds very boring. It's measuring dimensions of things, but it actually has a very important role to play in trade, international trade. So if you imagine an engine and they are building the pistons for the engine in Australia and they're building the cylinders for the engine in Thailand, then the cylinders have to fit inside, sorry, the pistons have to fit inside the cylinder, because otherwise the engine will not work. So it requires both nations having an established way of measuring that they agree on. So that's the sort of work I was doing. And then that filters through to Australian industry. So a lot of the work I was doing at CSIRO was also to do with translating our understanding of dimensions to Australian industry, because that would allow them to do international trade with partners in other countries. Because without that, there's no quality assurance that the components being built in Australia would be suitable for other places like Japan or China. So it was a really essential thing, and I spent a lot of time in China, in Asia. It was very, very, very interesting and very exciting work, and I think it was a fantastic way to start a research career.
Thank you. So that's great. We have a question from, I'm sorry, I can't pronounce the name, Binohaya. And how did you incorporate public policy directly into the research you did at the very first time? So this is, I guess, when you were a PhD student. And how did you break through the stigma that science, chemistry, researchers are not good for public policy? Thank you. So obviously,
another science student, yeah.
I disagree. Why aren't chemists good for public policy? No, I'm just kidding. That's a very fair question. I think I'll be honest with you. When I was doing my PhD, and as many HDRs as they're starting out, it's really not at forefront of mind. It really isn't. You're kind of pursuing things that you really you're passionate about in terms of the science itself, and then it's only later that you start thinking, well, but if I do this, is that going to harm the environment, or is this going to harm people, or is this going to have some other negative societal impact? And that's when you start delving a bit deeper into where you stand. I think today's PhD students and master students, they're in an advantage because most universities have like the Office for Research, Ethics and Integrity, ORI, here in QUT. And they provide a whole bunch of training and offerings to help people understand those sorts of things. I never had that back when I did a PhD back in the 90s. It wasn't a thing. So, but that emerged naturally. And then also once you start research projects in terms of collaborations, more and more people come on board, and you get to hear what their thought process is like, and they school you. So it's sort of like learning through experience. You see that somebody raises an issue about ethics and you go, oh yeah, I never even thought of that. And then you start thinking about that. And then next time you start another project, you go, oh yeah, but what about that ethics consideration we had last time? So we should probably look into that. So then you start to get that information that feeds into your projects in that way.
Is that I'm just looking at his question. Awesome, thank you. Yes, yeah. I'm just looking at the word stigma in the science area, and I think that I guess what comes up for me is that as a social scientist, I know that sometimes the social sciences don't understand the impact that scientists actually make in terms of policy. Don't see how it connects. I think, and I don't know what you think, I feel that the whole environment issue, the global climate environment issue, has really brought scientists to the fore. Would you agree with that?
I cannot agree more. That is exactly the case. And I mentioned before that the two areas I work in is the sensing and the photocatalysis. And if you look at some of the work we've done in photocatalysis, but not only us, but other research groups around the world, it's all now about trying to do that in a sustainable way, in a way where the environment's not harmed. So just to sort of point out where the problems are, in that most chemical reactions require huge amounts of heat. So energy has to be consumed to allow the thing to progress, to produce the chemicals that are desired. But all the work that I've been doing, because I'm a light-based person, is using sunlight. So we're trying to come up with a way to allow chemical reactions to produce essential chemicals to allow them to occur through this photocatalysis using sunlight. And that's the goal, to produce a more efficient and a more sustainable way of producing these things. And then also going the other way, there's just as big a body of work going into remediation. So if you have byproducts, how do we break those byproducts down so that they're not left there causing damage to the environment? So using the same sort of process or a similar process. So it's all about trying to use solar means to try and make these things happen so that we cause less of a problem for the planet in general.
Ask something that just popped into mind is my son's an engineer, and he was explaining to me that having a battery driven car, they use lithium, and
Yes.
he was saying to me, it's not necessarily the best, Mum. He said, because in actual fact, lithium is very difficult. It's harder to I don't know how to work with than uranium. So tell us about that, because he's told me some, but I mean, you're the scientist.
Well, there's a whole range of different researchers looking at different materials that can be used as a energy storage device as opposed to lithium. But there are other elements that the people are looking at instead of lithium for those reasons that you raised. The other problem about lithium is, and the one we're actually looking into, is that when you have a lithium fire, that causes lots of issues and problems. So we're looking at detecting, the byproducts that come off a lithium fire. But there's a whole range of different materials which they're looking at because of the issues with lithium. So again, I guess this points back to the earlier question about the stigma. So people in science are aware that these things are a big issue, and therefore they're looking for other means and other materials, including means that aren't conventional. So there's a whole bunch of concepts, such things as a water battery, basically where you use solar energy to evaporate water. It then gets transported to a higher level, and then you have a hydro scheme to recoup that. Of course, you can't run your car like that, but it's sort of other means which are definitely much more sustainable and cause less of a footprint or an impact on the planet are being pursued, and there's a lot out there. It's just that you don't hear about that a lot because there's a lot of noisy things, like all the big things that are very popular or controversial, they get all the press attention. And then you get politicians, I won't mention any names, who also sort of bang on about their pet, research thing, which is not research, but and that also distracts people from other opportunities or other viable options that could be explored even more. So yeah, there's a lot out there. I can't name any direct lithium alternative, but I was in a conversation just 2 days ago with somebody who was very switched on in that space and was talking about all the range of options that are being explored.
That's great. And because for me, it was like, I didn't know that, and he's made me aware, and now you've kind of confirmed it. But I'm kind of like seeing all this information about options, etc. And would you say that our social structures, in terms of the very wealthy, the ones with the more money and the big noises, actually tend to keep the information of new innovations like that quashed? I don't know. It's a bit of conspiracy.
There could be elements of that, but I reckon the biggest problem at the moment in the global society is the lack of trust in people who have education and knowledge. So pretty much, like people that are saying things that have been established in scientific fact. It could be in the medical realm, it could be in chemistry, science, whatever. This has been established for a long time, like with virus protection and the like. And then you have somebody who clings onto a vague statement or something that's really not based in science, put that forward as a fact. And I'm talking about influencers online who will grab different bits and pieces and paint this as the truth. And then all of a sudden, they've got 1 million followers who also believe the same story. And that just erodes the trust that people have in the people that have true possession of the knowledge and information. I'm not saying it's always correct. Scientists make mistakes and they, years down the track, but it's based on really thorough and rigorous studies. Whereas today in the social media world, somebody can just grab one fact, post it, and if they've got lots of followers, then all of a sudden it becomes a thing, and examples of that is people that are using medicines, really vital medicines to keep chronically ill people alive, are using it for cosmetic purposes, depleting the stock, which the people that need the medicine can no longer access. So I think that's one of the challenges that we have at the moment in the world, is this lack of trust in the people that have truly, have the education to give us sound advice, and then it's just being completely ignored. And it doesn't help that a lot of politicians also, are exactly the same, in that they just do not buy into things such as climate change or the disadvantages of nuclear energy and the like. I think there's a lot of there's a lot of conspiracy theory born out of all of that stuff, and then that makes it hard for people to trust a viable option.
Yeah, a lot of cognitive dissonance going on.
Yeah.
Gosh, there's something else I was just quickly curious. I know you have to go.
I'm going to have to go pretty soon. Yes.
Okay, just quickly, your contribution in the Asia Pacific regions through your fellowships. What work did you do there?
So that was, not at all. That was to do with the dimensional metrology, which sounds boring. It sounds like I've taken a ruler and I've gone across there and measured something, but it is kind of like that. But the sophisticated rules that we had back then were very exotic and sophisticated laser systems. So basically, the way that we could measure things like the distance between 2 points in space, like a meter, we could measure that as accurately as possible. And that turns out to be, we could measure 1 meter to 11 decimal places, which a lot of people go, well, why bother? Well, trust me, there are reasons why. Was to use a laser system, which we had to control in a specific way so that it had emitted light of just one specific color. And then we had to determine what that color was. And if we could do that, we could then do what I say, measure the gap between 2 points in space very, very accurately. So it's a very sophisticated bit of physics, actually, and it involves an area of chemistry and physics called spectroscopy. And so these things are basically done by people with a big background in the areas of lasers and physics. Yeah, or engineering as well, electrical engineering also.
And the benefits that are reaped from that?
Well, I think, like I said, is to make sure that there's uniformity. So,
Okay.
and that allows trading partners from different regions to be able to be confident that the products they're buying are built to specification. And so if you think about, the early example was about a motor engine. The reason that cars are much more efficient today is because the tolerances are tighter than they were back in the 1950s and 60s. So the reason that your old Holdens and the like consumed gallons and liters of petrol, much more so than, say, your little Toyota Camry today, is because of the fact that they were able to make the tolerances between cylinders and pistons much, much tighter. So that means the gap between those two surfaces could be made down to a micrometer as opposed to 10 micrometers. And so it makes a big difference in terms of efficiency and effectiveness. So those sorts of things. So that's an engineering thing. You should ask your son about that one.
Oh. I will, thank you. And look, I am cognizant that you need to go.
Yeah, I do.
Honestly, it's been an absolute delight. It's been wonderful. Thank you so much for sharing. I've learned heaps, and now I can have a more in-depth conversation with my son. And probably.
Well, I've enjoyed it too, and I hope the students as well have got something out of it. So good luck all, and I'll leave it there. So thank you.
Absolutely. Thank you so much. Thank you so
much. Thank you.
See you then. Bye. That probably, unless you have a question, we might move on. What do you think, Ola?
I agree.
Okay. So thank you very much, everyone. Thank you for participating. If you have any further questions or anything, use Blackboard and use the discussion. And really engage in the discussions this week. Some of them have just been absolutely incredible. Thanks a lot. Thank you and bye.
Thank you, everyone. Thank you, Anna.
Thank you, Ola.